Hello, this is Chuck Ridgway, Automation Technology Manager at Horner. Thanks for joining us for another Tuesday live stream. Well, if you're watching this live, you may have tuned in expecting to see setting up an AC power monitor using Horner OCS. But I made a last-minute decision. I discovered that if we save that topic until next month, I can give you a much more real-world showing, if you will, showing off that product in a real world situation at our factory. So I thought that would be a better session. So I decided to save that until next month. So instead, we're starting a short 2-part series. Here's the first part: data sorting operations in the Horner OCS. So again, we've got a short 2-part series. We're going to cover data sorting today and then array math next week. Now, to help me discuss data sorting, let me bring in our product manager, Mr. Casey Gardner. How you doing, Casey?
Hey, not too bad. How's it going, Chuck?
It's going pretty well. Now, sorting data isn't normally something you expect to do a lot of in a PLC, is it?
Not a lot. I think I've used it on one particular application where basically there were a number of weights that were being sorted, and it basically needed sorting them from lowest to highest and keeping up to like 3 to 5,000 at a time. So that was the need.
Yeah, it's normally something that's reserved for, computers, right? Databases, those sorts of things. Maybe even Excel spreadsheets. Not something you do all the time on a PLC, but we're going to show you how to do it today. And while I'm showing the material, Casey will be standing by to answer any questions you might have. If you're watching live, give us those questions in the chat section. If you're watching on replay, we'd love to see your comments and questions in the comment section. All right, let's take a look at how we're breaking down the topic today. Okay, we're going to start by talking about some example applications, and Casey gave us one just a minute ago. We're going to talk about how data sorting logic works in general. And then I'm going to show you the data sort user-defined function blocks that we've created to make your job a lot easier if this comes up in your next application. And of course, we're going to show you how those work. Let's get started. So what are some examples of different applications for data sorting? Well, let me give you an example here. So let's say that we're using the OCS for machine control, but we're also using the OCS during, let's say, a test cycle, or maybe a test mode of the equipment, maybe after we've done some sort of a machine changeover to a new part, or maybe when we've just made some radical changes to our process control parameters, and we just want to make sure everything's working properly, and we're going to execute kind of a special test mode in the machine. So that might be a scenario where you're going to capture your process parameters, and maybe as part of that analysis, you might want to sort that data, that process data, in numerical order as part of your analysis. So that's the example that I'm giving here. Casey gave you another example that he had run into in his experience. Okay, but let's now talk about data sorting in a PLC. Well, the reason it's not done that often in a PLC is because it can be processor intensive. And for that reason, you often find it on computers or doing the sorting on computers, offloading the PLC. However, we're going to show you today how you can do it quite easily and quite safely, if you will, in the Horner OCS. And we're going to use something called a bubble sort algorithm that we're going to apply in a user-defined function block so that you can just use that UDFB as we've written it to really make sorting data nice and easy. So what is a bubble sort algorithm and how does that work? Well, let's give the example where we're sorting data from low to high, kind of like Casey had to do. We're going to use a bubble sort algorithm to make that happen inside of our user-defined function block. So the way that works is you start at the beginning of a list of data. This is how a bubble sort works. And then you start by comparing the first two values in your list. And if the first value is larger, you're going to swap the position of the two values. Then you're going to move on to the next value in the list and do another compare. Again, if the lower value of the two is larger, then you're going to swap. And you're going to keep on going until there's no more values to compare in your list. Now, you have to go back to the start of the list and repeat, and you're going to go through the list in its entirety multiple times. Those are called passes. And you know you're done when there are no more values that need to be swapped. So whenever you make a complete pass and there's no swaps that occurred, you know everything is in the proper order. Now, why is this tricky in a PLC? Because that algorithm sounded kind of simple. Well, it's tricky in a PLC because you need to execute a loop. And in PLCs, loops can be problematic. If they're not handled carefully, you can end up with an infinite loop. And not only is it tricky because you need to loop, but because you need to make multiple passes through a loop. So the larger the amount of data, or the larger the array you need to sort, and the larger the number of passes that you need to go through the data to accomplish the sort, it can also have an impact on scan time. So in some scenarios, you'll find data sort routines in PLCs which are limited to a certain number of passes per scan. In our case, we're going to limit it to a certain size of an array to kind of keep it from going off the rails, if you will. So let's talk about the Horner data sort user-defined function blocks that we're introducing today. Again, they're designed to make sorting data easy in a Horner OCS. Inside of the user-defined function block, we've got bubble sort logic taking care of all the loops and the multiple passes. And the end result is we have 6 UDFBs for you to use that will be posted shortly on our website with this recording of this video. And there are 6 different routines, or 6 different UDFBs that we're making available. You can sort up and sort down for all of integers, double integers, and real. So there's 6 different UDFBs available for you to use depending on what data type you're using and whether you want to sort up or sort down. Okay, let's take a look at the details at the inputs and the outputs of the UDFB. So there's an enable input that has to be on to enable the sort. Now, the way this routine actually works is it actually performs the sort on the first scan after the enable bit has been enabled. So it only takes one scan to do the sort. And after that, as the function block remains enabled, it just basically does nothing. It's done executing. Now, the next input to talk about is the input array, or the data that needs to be sorted. So you're going to have an array of data. Maybe it's test results, maybe it's production data, whatever the case may be. And that is going to be the array that is going to be sorted. Now, the function block doesn't actually touch the input array data. It leaves it alone. Okay, so that will remain intact when the sort is complete. The third thing to specify on the input side of things is the length. How many elements in that input array need to be sorted? So, and we can support lengths of up to 100. So in the future, we'll expand this beyond 100, but for now, it's limited to arrays up to 100 in size. Okay, on the output side of the UDFB, there's a done bit that tells you that the data has been sorted. You've got the output array. So that's the data that has been sorted in an array. Now, another thing that's provided as an output, just as kind of a piece of information, is an integer value called pass count. So that is how many passes through the data it was required to sort the actual data that you just executed. So depending on how the data is arranged in your array, it may take a lot of passes or it may take only a few. And then finally, there is an error bit that can be set if you've set the length parameter incorrectly. So if you forgot to set your length to a value greater than 0, or you've set it to a value greater than 100, then you're going to get an error flag to turn on. Okay, so the logic within the user-defined function block, again, not logic you have to execute, but what the block is executing for you. Here's kind of a schematic view of what's happening inside the block. So as soon as the block is enabled, it performs an error check, and then provided the length parameter is set appropriately, it starts out by taking the input array data and copying it to the output array. So again, it doesn't touch the input array data. It just uses it as the initial source of all the data. Once it's copied into the output array, again, it starts out in the same exact order as it was presented in the input array. Then we start going through and making passes and start rearranging the data. Okay, so and again, we start, because we're executing a bubble sort, we start by comparing the first two values in the list. If the lower value is larger, we perform a swap. Of course, this is the logic if you're arranging from low to high value. And then we're just keep moving on through the array until we get to the end. And if we get to the end and we had to do at least one swap, we do another pass. And we keep making passes until we don't have to do any swapping through one complete pass. And then we're done. Okay, so that's effectively the diagram of what's happening inside of the logic. And now let's fire up Cscape and take a look at this in action. All right, so let's take a look first of all at the user-defined function block as you will use it. And it's available and will be available through the UDFB section of your toolbox. But the only reason it shows up there is because you have imported it. Now we're going to post these UDFBs on our website. So if you're watching this on replay, very likely you've already downloaded those. And the way you import those is as follows. So you go to the Logic Modules area of your Project Navigator, you right-click, and you say Import Logic Module, okay? And then you navigate to the folder containing the CPU file, which you downloaded from our website, and then you type in star.cpu, so that it can find any CPU files, which is the format that UDFBs are in. You select the one you want and you say open, and it will import it. Now I've already imported it, so I'm not going to do that again. But once you've imported it, it shows up down here under UDFB modules, and then after that it's available to pull from here. So you can just click it and drag it onto your project. Now I'm going to go ahead and cancel that out because again, I've already got one on my desktop here already in use. So once you've placed the UDFB on your desktop, the first thing it's going to do is to effectively want you to name the UDFB. Why is that? Well, that's because, remember, one of the beauties of having user-defined function blocks is that you can have multiple instances of them in the same program. So if you have 2 or 3 different arrays that you need to sort, no big deal. You can go ahead and have 2 or 3 different data sort UDFBs that you're using in your program, one per array that needs to be sorted. So that's one of the conveniences of UDFBs. Okay, and then you just assign your inputs, your input variables, and your output variables. Now, these don't have to be variables. For instance, maybe you're always going to be sorting an array that's 50 elements long, has a dimension of 50. Well, you could just type in a hard number or a constant of 50 for the length. You don't have to assign a variable to it, but in my case, I did go ahead and assign a variable here. Okay, so here's the array of data, and we always, whenever we specify an array with a UDFB, we always specify the first element in the array. So that's element 0 here. So this is the input data that's going to be sorted. And then we've also specified as an output array, another array, because remember, we don't touch the input data, we leave it intact, but we copy it as part of the logic inside the UDFB, and then we perform the sorting and report the sorted data as the result array. Okay, and then we've got an enable bit as well as an error bit and those sorts of things as well. Okay, so that's how you would apply it. Now, just for fun, I'm going to go ahead and walk through the logic inside the UDFB. Keep in mind, this is, to some of you, this is irrelevant because you can just use the user-defined function block and you don't need to worry about the logic inside the block. But I thought it would be fun to share that with you as part of our live stream today. Okay, so what's happening inside the UDFB? When the function block is not enabled, effectively all the output variables are set to 0. So that's the first thing that happens. Now, I mentioned earlier that the actual data sort happens on a single scan. So all the looping and all the passes we make in the UDFB to perform the sort, those are all done on a single logic scan. So what we do here is we turn on a one-shot bit that we're going to use for all the logic as we're going through our loops. That tells us, yep, this is the first scan after the enable, so it's time to execute that logic. Now, the first thing we do once we've established this one-shot is we check and make sure that our length of the array that we're going to be sorting is in a legal range. So it can't be 0 and it can't be greater than 100. If either of those two cases is true, we set an error bit and we jump immediately to the end and don't do anything else. The other time we jump to the end and don't do anything else is on the second pass after this function block has been enabled. Why is that? Well, there's no reason to continuously resort the same data over and over again. That's just wasting CPU time. So from the second pass after the UDFB is enabled and on, it's just going to immediately jump to the end. But on the first pass, we have a lot of work to do, and let's go through that. Okay, so we start by setting our index values. Anytime you're going to be doing a loop, whether you're talking about ladder, or you're talking about structured text, or you're talking about any other language, there's going to be an index as you work your way through the loop. Back in elementary or middle school, it was the for I equals 1 to 10 type for next loop in BASIC. And the I was our index. Okay, so we've got to have an index, so we set those variables to their initial value. And then the first part of the logic is just a short loop that goes through and copies the input array to the output array. So again, we don't touch the input array, we just copy it over to the output array, and the output array starts out in the same order as the input array. Okay. Next, this is where we have our logic, which is going to go through and perform multiple passes. Now, every time we start a pass or we get ready to start a pass, we reset our indexes back to their initial values. And then as we're executing the pass, we are loading a couple values to compare, performing the compare, determining if the values need to swap or not. And then if they do, we perform the swap. Now, if we do need to perform a swap, we also set a flag so that we can know at the end of the pass that, yep, we had to do at least one swap, so we're going to have to do another pass in the future. Okay, once we fall out of that loop, then again, we check to see if we had a swap that occurred on the previous pass. If we did not, in other words, we've making enough passes where there's no swapping that is happening, then we are effectively done. Okay, so that's what's going on inside the UDFB. But once again, all you need to be concerned about is using the UDFB, which I have shown you earlier. All right, let's head to the benchtop now and take a look at a little demonstration on the bench. So what I have here, we're going to start small. What I have here is an array of test data that only has 10 elements to it initially, or 10 data values. And this is the values as they were originally captured. And then over here in this next column, those are the sorted values. Now we have not enabled our UDFB at this stage, so those values are all fixed at 0. Now, if I forget to set my length in my sort routine for my UDFB and I try to start my text, I just immediately get an error because again, my length has to be greater than 0 and not greater than 100. All right, let's start with a simple 10 piece sort here, which should be able to sort all this data. I'll go ahead and hit the start button, and there we go. Our result is we've sorted the data from least to greatest because that's the type of sort we want to accomplish here. For informational purposes, you can see it took us 7 passes through the data to actually get everything completely sorted. Okay, so that was pretty straightforward enough. Let's take a look at another scenario where maybe we have a little bit more data. Okay, so I could show you, let's say, 100 values on my test screen here, but the print would be pretty small. So what I did instead was I'm showing you the first 10 values and the last 10 values. So the middle part of the array from index 10 to index 89 is just not shown on the screen here. And the data source I'm using in this case, I've got similar data to what you saw before, and then mostly a bunch of zeros everywhere else. So after I sort this data, you should see the non-zero values show up towards the top, and the 0 value showing up towards the bottom. So let's change our amount of values to sort to 100. Oops, there we go. And now let's go ahead and perform the sort. All right, so now what you see is the low values. There's a bunch of zeros there. So of course, they're in the low part of the sorted data. And then our non-zero values, they ended up at the top end there, because it just so happened that I only had 10 non-zero values and the other 90 values were all 0. Okay, but let's say we want to look at this in a graph or something. Well, I can easily graph this data. Let me switch to a graph screen here, and I'll hit the graph results button here in my example. And you can see I've got in red here, I've got to look at my data from least to greatest, and we can see that a vast majority of the data during my test was 0, but that we did get some values ranging all the way up near 1,000 as being the largest values that we got in our test. So for certain types of testing that you would be doing, this could be useful information. Anytime you slice and dice data in a slightly different fashion, sometimes you can really learn a lot from it. So this is a way that you can quite easily sort data in a Horner OCS, and maybe as a result of that, graph the results. So that pretty much wraps up the material that I wanted to show you today. Let's go ahead and wrap up our topic. Data sorting is a useful function that is often reserved for computers instead of PLCs, and that's because it can be processor intensive and has the potential to impact your scan time. Now, the data sorting UDFBs that we've made available to you now for Cscape, they provide a practical means of sorting data values on arrays with a dimension of up to 100, and I'm sure in the future we'll also make some UDFBs available for sorting larger arrays as well. We'll just probably limit the number of passes that can be made at any one processor scan to say 100 or less, I'm guessing. All right, so this is the point in the program where I remind you that we're here every Tuesday at 2 o'clock, whether we're fully live like today or whether we're pre-recorded. And of course, we love to see your comments and your questions in either the chat section if you're watching live or the comment section if you're watching on replay. Don't forget, this is our 10th anniversary of Horner Lighting Products. Check out their videos on the Horner APG YouTube section right alongside our great automation content. And next week, we're going to talk about some more array fun, and that is array math. So maybe you've got an array's worth of test data or any other kind of data, and you need to find the average or the max or the min. We're going to show you how to do that next week in our live session Tuesday at 2 o'clock. If you haven't subscribed to our channel, don't hesitate to do so. It doesn't cost anything. And if you choose notifications when you subscribe, you'll also receive a notification every time we go live or every time we post a new video. And there's usually multiple videos per week in addition to our live streams, which happen every single Tuesday. All right. So until next week, let's all get out there and do us some good.